Hello, welcome to the Machine Learning at Home. Today I will speak about multivariate normality. Many methods which want to work with multiple variables also want that all variables will be normal, and is more important that the variables all together should be normal. So the whole of your data should belong to multivariate normal distribution. This is interesting condition and not many people are checking it. So I will show today how to check it. First of all, we'll use very simple data, same iris data again, and also we'll use the new R package, library MSQC. This library contains multiple multivariate normality tests. Well, at first I will run univariate normality. So for each variable I will check is it normal or not. And again I will take iris data. How to check simultaneously for the 4 variables, because iris data without fifth column contains 4 variables. So I prefer to write a small function. So function will be norm. This is a name, and this is function which will do what? It will run Shapiro-Wilks test. Shapiro.test, and we'll take p-value from that test, p-value, and then if p-value is equal or more than 0.05, well, then we consider distribution as normal. So I will use if-else. So if-else Shapiro test p-value is more than 0.5, I will output normal in uppercase, which means that data conforms the normal distribution. Again, I speak only about one variable at the moment. Or if it's reversed, like it's less than 0.5, okay, that will be not normal. And this is it. So I only need to count how many parentheses we have. I think I need one more. Okay, and this is my function. No, something wrong. Still didn't count parentheses properly. Function x. In that case, everything should be correct. Of course, if you define function, you should first define which variable will be within, so function x. Okay, so we made it, and now we can run sapply for iris without fifth variable, comma -5, and our new function norm. Okay, I made another mistake, and I will not remove this from video, because I like you to see which mistakes anybody can do, including myself. If else. Okay, and now I can finally run it. Yep. Okay, actually I can run Shapiro test 4 times and spend similar time than when I spent to make my new function and also make it working. But anyway, this is more funny, and this new function is good for, well, some other data if you like. So I like this function anyway. And now I want to check another one. So this is a bit suspicious, as you see. My results show that only one variable is actually normal, and 3 other variables do not conform with normal distribution. So that's not a perfect data for many types of multivariate analysis. For example, for linear discriminant analysis. Let us check the multivariate normality. Again, this is a test which is extension of Shapiro test. It calls Royston test, and that test checks if the whole data is a result of some normal distribution alike process. So this is why we loaded MSQC package. So you can simply call Royston test directly, but I like to modify my norm function and make it, for example, mnorm. And then instead of Shapiro test, I use Royston test. This is a test from package msqc, so you need to load it first or install it. And then slightly different interface, only slightly, p-value. And if it's more than 0.0, otherwise everything is very similar. Okay, so function by itself doesn't do anything, but now we can apply it, and as apply is not needed because that function is applicable to whole data. So we can use the whole data and simply apply our function mnorm. Not. Well, disappointing answer, because as you probably remember from textbooks of multivariate analysis, ARIS data is frequently used for illustration, for example, of linear discriminant analysis, and linear discriminant analysis wants data to be multivariate normal. On the other hand, this is not very bad, because, well, this normal distribution requirement is not absolute. It doesn't mean that if you see your data doesn't conform with normal distribution, you should simply throw it away and collect new data. No. This is okay. You only need to tell others that your data is not exactly going well with a normal distribution. So methods which you use for analysis of your data are good, but not perfectly good. So this is what means not here. So you still continue to use these methods, but you should be aware that they sometimes might not show you the very good answer, the proper answer. So again, this is how to check multivariate normality. Important thing when you work with multiple variables. And this is all machine learning is about multiple variables. So this is it for today. Thank you so much.